Did you see that crazy spiral glowing in the sky above the UK a few nights ago?
I did. It was all over my social media feed. Wild stuff.
Yeah, for a few minutes, everyone online was buzzing, trying to figure out if it was, aliens.
Huh, of course. It did look pretty strange, didn't it? Just hanging there, spiraling and growing.
Yeah, it looked really out there. But as much as I'd love to dive into some alien conspiracy theories, the truth is, well, the truth is actually pretty amazing too. Turns out that whole light show was caused by a SpaceX Falcon 9 rocket.
That's right, a Falcon 9. And launched all the way from Cape Canaveral, Florida.
Yeah, from Florida across the Atlantic and up into space, leaving that crazy spiral trail visible over the UK. And get this, it was on a mission for the US government. Top secret stuff.
Definitely adds a layer of intrigue, right?
Totally. So that's what we're diving deep into today, this Falcon 9 rocket, the one responsible for creating that amazing light show. We're going to figure out what makes it tick and, more importantly, why its exhaust turned into that mesmerizing spiral.
We've got some excellent sources for this deep dive. First, a really detailed Wikipedia entry on the Falcon 9, packed with all the technical specs and history. And then we've got a news article that covers the UK spiral sighting, giving us the first-hand accounts and reactions.
Perfect. Now, I think it's safe to say that our listeners here are pretty familiar with SpaceX and, space stuff in general.
Yeah, they're a pretty well-informed bunch.
But we're going to break it all down anyway, make it clear and fun, whether you're a total space nut or just someone who happened to catch that strange light in the sky and was curious. No need to get lost in rocket science jargon here.
Exactly. We'll keep it engaging, highlight those aha moments, and hopefully give everyone a solid understanding of what makes the Falcon 9 so special.
Sounds good. Okay, let's rewind a bit. A Falcon 9. Where did this rocket even come from? How did it all begin?
Well, the story actually starts back in 2005 when SpaceX first announced their plans for the Falcon 9. It was a pretty ambitious project right from the beginning.
2005, that's a while back. And they didn't actually launch the first one until 2010, right?
You got it. 5 years of development before that first liftoff. But what's really interesting is the whole funding aspect. The primary investment came from private capital, SpaceX's own money, but NASA actually played a key role in those early stages.
Oh, yeah, I sort of remember that. Wasn't it through that Commercial Orbital Transportation Services program, CONS?
You got it. SpaceInfo. NASA was looking to get private companies more involved in spaceflight, specifically in resupplying the International Space Station, the ISS.
Right, right. Outsourcing to the private sector.
Exactly. And through CONS, SpaceX received payments for achieving certain development milestones and for conducting those first crucial demonstration flights. It was a kind of partnership, really.
I see. So how much did NASA end up contributing to the development of the Falcon 9?
In total, NASA put in $396 million towards both the Falcon 9 and their Dragon spacecraft, which is designed to carry cargo and crew to the ISS. But SpaceX themselves invested even more, over $450 million. So it was a substantial commitment from both sides.
Wow, that's a lot of money. Shows how much they believed in this project. But hey, before we get too deep into the technical stuff, I got to ask the name Falcon 9. Where did that come from? Any cool story behind it?
Oh, there definitely is. Elon Musk, the founder of SpaceX, is a huge Star Wars fan. And guess what? The Falcon 9 is a direct nod to the Millennium Falcon. Apparently, they even considered a smaller rocket design called the Falcon 5 at one point.
That's awesome. It all makes sense now. All right, back to the early days of the Falcon 9. When SpaceX first dreamed this thing up, what were they hoping to achieve? What was their vision for this rocket?
Their vision was pretty bold right from the get-go. They wanted to create a fully reusable, heavy-lift launch vehicle. Think about that. Fully reusable. No throwing away expensive rocket parts after just one use. That was a game changer.
Ambitious, for sure. But what about the actual performance goals? How much weight were they aiming to get into orbit?
Well, their initial targets were to lift about 9,500 kilograms, that's over 20,000 pounds, to low Earth orbit, or LEO. That's the region a few hundred to a couple thousand kilometers above Earth where a lot of satellites hang out. And they were aiming for a price per launch of somewhere between $27 and $35 million.
Wow, those are some serious goals, especially back in 2005. But we all know things change, technology evolves. There's no way the Falcon 9 we see today is exactly the same as the one they first envisioned, right?
You're absolutely right. The Falcon 9 has gone through some major evolution over the years. There have been several different versions, each more powerful and capable than the last. It's a constant process of improvement and refinement.
Okay, so let's break down those versions. What were the main stages of the Falcon 9's evolution?
All right, so first up, we have the V1.0, the original. It flew 5 times between 2010 and 2013. Then came the V1.1, with 15 launches from 2013 to 2016.
Okay, so those were the early birds, the first generation. What came next?
After the V1.1, we got the full thrust version, sometimes called Block 3. This one had a good run, with 36 launches between 2015 and 2018. Then we had the Block 4 versions in 2017 and 2018, relatively short-lived. And finally, the version that's currently flying is the Block 5, in service since May 2018.
So considering when that spiral appeared over the UK, chances are it was created by a Block 5 or maybe a late full thrust variant.
Most likely, yeah.
And through all these upgrades and versions, there was this increasing focus on reusability, right? Turning rockets from single use to, well, more like airplanes, able to land and fly again. When did that become a key part of the Falcon 9 program?
The real push for reusability started with the full thrust version. That's when they really began incorporating all the technology and procedures needed to recover and reuse that first stage booster. It was a huge step forward.
Absolutely. I mean, landing a rocket upright, that's some serious science fiction stuff come to life. But before we get to how they pull that off, let's talk about the Falcon 9 itself, the actual design and those cool specs that, contribute to that crazy exhaust plume we saw. The one that created the spiral.
Right, let's get into that. The Falcon 9 fundamentally is a two-stage-to-orbit medium-lift launch vehicle. Both stages use liquid oxygen, or LOX for short, as the oxidizer, and rocket-grade kerosene, known as RP1, as fuel.
So LOX and RP1, that's the magic formula.
You got it. Now, when we talk about how visually impressive the Falcon 9 is, its sheer size is a big factor. For example, the full thrust version is almost 70 meters tall.
That's like, what, 230 feet?
Yep, 230 feet. It's a giant. And it has a diameter of 3.7 meters, about 12 feet, with a launch mass of nearly 550,000 kilograms.
That's over 1 million pounds.
Insane. But, okay, all that size and weight, how does it even get off the ground? What kind of engines power this beast? All right, so the first stage, the one that does the heavy lifting at liftoff, is powered by 9 Merlin 1D Plus engines. And they're arranged in this really clever configuration that SpaceX calls Octaweb.
Octaweb. Sounds cool.
It is. It's a tightly packed arrangement that gives them both redundancy in case one engine fails and optimal thrust. Together, these 9 engines generate an incredible 7,600 kilonewtons of thrust.
So that's the muscle, the raw power. How long do those engines burn for?
The first stage engines burn for about 162 seconds. Then the first stage separates, and that second stage takes over, carrying the payload the rest of the way.
And the second stage, what's powering that?
The second stage has a single Merlin 1D vacuum engine, specifically designed for the vacuum of space. It generates about 934 kilonewtons of thrust and burns for a longer duration, around 397 seconds. And it's this second stage that's responsible for that glowing spiral we saw.
Okay, now that's what I really want to understand. We've got the launch, the power, the 2 stages. But where does the glowing spiral fit into all of this?
It's all about what happens after the first stage separates and starts heading back down to Earth. That second stage, after it's done boosting the payload, often needs to shed some extra weight. To do that, it vents any leftover fuel, the RP1 kerosene, into the upper atmosphere.
Wait, so it just dumps fuel out in space?
Pretty much, yeah.
Yeah.
And here's where it gets cool. In the super cold, thin atmosphere up there, that kerosene freezes almost instantly. It forms this expanding cloud of ice crystals.
Ice crystals from rocket fuel. That's wild.
It is, and because of the motion of the rocket, it's often tumbling a bit as it vents that fuel. The cloud forms this spiral shape. And then when sunlight hits those ice crystals, it gets reflected and refracted, creating that amazing glowing effect we saw. It's pretty stunning.
So it's basically frozen rocket fuel catching the sunlight and putting on a light show for us down here on Earth. Way cooler than aliens, I gotta say.
It's pretty spectacular, right?
Definitely. But let's circle back to that first stage for a second. You mentioned it heading back to Earth. That's the whole reusability thing, right? Landing a rocket upright. How do they pull that off?
It's pretty amazing to watch. So once the first stage separates, it flips around and uses its engines to slow itself down and start heading back towards Earth. It deploys these grid fins, which act like aerodynamic control surfaces, steering it through the atmosphere.
Grid fins, are those the things that kind of look like, I don't know, like big metal X's sticking out from the rocket.
Yeah, exactly. And the newer Falcon 9s use titanium grid fins. They're stronger, more heat resistant, and better at maneuvering than the older aluminum ones. And then right before touchdown, the landing legs deploy.
Landing legs, grid fins, titanium.
Yeah.
It all sounds super high tech.
It is. And the whole powered descent and landing system is a big part of why SpaceX has been able to achieve this level of reusability.
Hmm.
They actually tried using parachutes to recover the first stage in the early days, but it didn't really work out.
Parachutes. Seems a bit low tech for SpaceX.
Yeah, they quickly moved on from that and focused on powered descent using those Merlin engines, and it's proven to be far more effective and reliable.
Okay, so the first stage lands, they reuse it. What about the second stage, the one that makes the spiral? Do they recover that too?
Not at the moment. Reusing the second stage would be a lot more complex. It would need a heat shield, landing engines, all that extra stuff, and it would add so much weight that it wouldn't be practical. It would significantly reduce how much payload they could carry.
Makes sense.
Mm.
There's always a trade-off, isn't there? Now, the Falcon 9 has been flying for over a decade, racking up a lot of missions. Can you tell us a bit about its launch history and how reliable it's been over the years?
Sure. The Falcon 9 has a pretty impressive launch cadence, meaning how often they launch it. In 2022, it set a new record for the most launches by a single rocket type in a year. 60 successful missions. That's more than one launch per week on average.
Wow, that's incredible. They were really pumping them out. And by 2024, they'd already done a total of 134 Falcon flights.
Yep, a busy schedule for sure.
But all those launches, what about reliability? Have there been many issues?
As of March 2025, the overall success rate is 99.35%. Out of 454 launches, they've had 451 full mission successes. And the Block 5 version, the latest one, boasts a 99.7% success rate.
It's pretty darn good,
Yeah.
especially when you consider they're launching valuable satellites and, people into space.
Right, reliability is key.
But I do remember hearing about a few incidents recently. What's the story with those?
Yeah, there have been a few incidents that raised some concerns, especially in late 2024 and early 2025. There was an upper stage engine failure in July 2024 during a Starlink launch, and that resulted in losing the payload. Then in August 2024, a booster tipped over and was destroyed after landing on the drone ship.
Okay, so a couple of mishaps. Anything else?
Yeah, in February of this year, 2025, there was an upper stage issue that prevented a deorbit burn, and that led to an uncontrolled reentry of the upper stage. And then just this month, in March, a booster was lost after landing on a drone ship. Seems like it was a fuel leak during ascent.
That's a few more hiccups than we're used to seeing from SpaceX. Did those incidents raise any red flags?
They definitely prompted investigations to figure out what went wrong. And NASA's Aerospace Safety Advisory Panel did express some concerns. They suggested that the rapid pace of launches might be putting pressure on safety practices and maybe affecting the thoroughness of their analysis and, how they fix things. But they also acknowledged that SpaceX has been pretty transparent about these issues and committed to addressing them.
Makes sense. It's a delicate balance, right? Pushing the boundaries of spaceflight while also maintaining top-notch safety standards. Speaking of safety, you mentioned something earlier about an engine-out capability. What does that mean exactly?
That's a crucial design feature, and it means that the Falcon 9 is designed to keep going even if one of the first stage engines fails during flight. It can compensate by burning the remaining engines for longer. It's kind of like having a backup plan built right in.
So it's like redundancy, like having a spare tire.
Exactly. They actually demonstrated this back in 2012 on the CRS-1 mission. One of the first stage engines failed, but they were still able to deliver the cargo to the ISS. Pretty impressive.
Super impressive. Okay, so let's zoom out a bit. Beyond just SpaceX and their achievements, what kind of impact has the Falcon 9 had on the space industry as a whole? Has it been influential?
The Falcon 9's success, especially its reusability aspect, has had a huge ripple effect throughout the entire industry. Other space agencies and companies are now racing to catch up, trying to develop similar technologies.
So they've set a new standard, and now everyone's playing catch-up.
Pretty much. In Russia, for example, they're developing the Soyuz 7 rocket with a reusable first stage, just like the Falcon 9. And in China, Tianbing Technology has explicitly stated they're benchmarking their Tianlong 3 rocket against the Falcon 9.
Makes sense. Everyone wants a piece of that reusable rocket pie. But beyond the technology, how has the Falcon 9 impacted the economics of space travel? Cost is a major factor for anyone wanting to get something into orbit.
Absolutely. SpaceX's lower launch costs, largely due to reusability, have put a lot of pressure on their competitors to offer more affordable options. It's created a whole new level of competition, which is ultimately good for everyone involved, especially those looking to launch stuff into space.
And those lower launch costs, they've also opened up some really interesting possibilities, haven't they? Like those rideshare programs I've heard about. What are those exactly and how do they work?
Rideshare programs, things like Transporter and Bandwagon, are basically regularly scheduled Falcon 9 launches that are designed specifically for deploying lots of smaller satellites. So instead of a small satellite having to wait for a larger mission to tag along with, they can now hop on these dedicated rideshare flights. It's like a space carpool.
Space carpool, I like that. So smaller companies, research institutions, even universities, they could all get in on the action now.
Exactly. It's made space far more accessible than it used to be, which is exciting. It's democratizing access to space.
It really is.
Yeah.
So from that mysterious glowing spiral we saw in the sky to this fundamental shift in how we access space, the Falcon 9 is at the forefront of it all. A pretty remarkable rocket, wouldn't you say?
Absolutely. That spiral, it wasn't just a cool visual phenomenon, it was a tangible reminder of how far rocket technology has come and how it's changing our relationship with space.
It really highlights that aha moment, doesn't it?
Right.
Something that seemed mysterious and even a bit spooky at first and turned out to have this fascinating scientific explanation.
And as these space activities continue to grow with more launches and more ambitious projects, it really makes you wonder what other unexpected sights we might see in the sky. What other visual spectacles are in store for us?
That's a great question to ponder. And this deep dive has just scratched the surface of the Falcon 9 and all its capabilities. There's so much more to explore. Maybe that's something our listeners can do on their own, dig a little deeper into this world of reusable rockets and space exploration. It's a fascinating rabbit hole to go down.
Definitely. And who knows, maybe one day they'll spot their own mysterious light show and be able to explain it to their friends.
Wouldn't that be something?
It would.